Welcome back. Thank you so much for watching today. In this episode, we will be discussing the Interplanetary File System. Stay tuned for IPFS Simply Explained. The internet is the most important tool in our everyday lives. Not a day goes by where we're not checking YouTube, Instagram, sending emails, texts, or other communications. However, the internet we all love has its flaws. The biggest of those flaws is that the information contained on the internet is mostly centralized. This means the information we access every day is housed and controlled by several large companies. The mission of the Interplanetary File System is to create a distributed internet. IPFS is a peer-to-peer hypermedia protocol designed to make the web faster, safer, and more open. Centralization poses many issues. Centralized servers are a single point of failure. They become the target of hackers because the information contained is so valuable. IPFS was created by Juan Benet. He is also the founder of Protocol Labs. Protocol Labs is a tech, research, and development lab that is responsible for IPFS. IPFS was created as an efficient way to move scientific data sets. This means files that could be anywhere between 10 and 100 gigabytes in size. It was designed to look like a merger of GitHub and BitTorrent. BitTorrent gives you the ability to move large files across a network quickly, and GitHub gives you built-in versioning for your data. In just a moment, we'll dive into how IPFS works as a filing system. But first, it is important to understand how we access files from the internet now. When you want to access a file from the internet, you tell your computer exactly where to find the resource you are requesting. This location is normally in the form of a URL. This method for accessing resources is called location-based addressing. The main problem with this solution is if the server is offline, no one can access the information. To help address this issue, IPFS introduces the concept of content-based addressing. With content-based addressing, when requesting a specific resource, you do not need to specify the location. You only need to specify what it is you're looking for. Every file is assigned a hash. This can be thought of as a fingerprint, a unique identifier for the file. When you want to access a specific file, you simply ask the network who has a copy of the file with a specific hash. Once the request is made, someone on the IPFS network will provide the resource you have requested. Now that you understand the basics of the Interplanetary File System, let's dive a little deeper into data storage. Using IPFS, files are stored in IPFS objects. An IPFS object can store 256 kilobytes of data. Objects can also contain a link to another object. Linking is what makes it possible to store data that is larger than 256 kilobytes. In the image above, one object is enough to store a small text file. Let's imagine you are storing a picture that is larger than 256 kilobytes. This will be broken up into multiple objects. The IPFS system will then create an empty object that will link to all the objects that make up that picture. Now let's compare a traditional file directory structure with the IPFS file structure. In a traditional structure, you have a main folder with several files and subfolders inside. With IPFS, each folder and file is its own object. These objects link to each other when necessary. Another great thing about IPFS is the ability to support versioning. This works similar to how GitHub works. When a new file is added to IPFS, the system creates a new commit object. The purpose of the commit object is to tell the system the order that the files were added in. Commit objects link up the same way regular objects do. This allows for file versions to be stored in sequential order. I hope you have enjoyed this brief introduction into the Interplanetary File System. Please leave a comment below letting me know what the next topic should be. You can always read more at achainofblocks.com, and please consider subscribing below.